This is section 2.5, Applications of Linear Equations and Modeling. We are going to first apply the point-slope formula. And we now learn another equation for a line. And as you can see, this equation uses a point and it uses the slope. So let's give this a try. Use the point slope formula to write an equation of the line having the following conditions. Write the answer in slope-intercept form if possible. So once we use the point slope formula, then we'll solve for y, okay, to get this slope-intercept form. Okay, so we have a point and we have a slope. So we will have y minus this y value equals the slope right here times x minus the x value. So we have y minus 2 equals 2 times x plus 4, and that's 2x plus 8, distributing that 2, and then adding 2 to both sides. We end up with y equals 2x plus 10. Okay, and now we will go ahead and graph that. And if you remember from the previous lesson, the y-intercept is 10 and the slope is 2, and we'll write it as 2 over 1. So we'll go ahead and put that intercept, that y-intercept of 10, and we will go up 2 over 1. You can also go down 2 to the left 1. So that makes it pretty nice. Okay, let's try this next one. We're given a point and a slope. So we have y minus the y value equals the slope times x minus the x value. So this is just y equals negative 2/3 x plus 10/3. So we will note that we have a y-intercept of 10/3 and a slope of a negative 2/3. So placing this y-intercept, 10/3 is just above 3. About right there. And it might be easier this time to begin with this point and then use the slope since we have a fraction. So we could also write the point is 5, 0. So since this is a fraction, we can actually have a better sketch. 1, 2, 3, 4, 5. There's that point. And now with this slope, we're going to go down 2 to the right 3. We can also go up 2 to the left 3. And then connecting these points. We can plot it just like that. Okay, looking at number 3, what do you notice? We have 2 points, but we don't have the slope. So we will need to find m, and then after we find m, we can choose either point to use. since they're both points on the line, we can choose either point, okay? So let's start with the slope. The slope is 1 minus a -4 divided by a -2 minus a -1. And that gives us 5 over -1. So we have a slope of -5. Now that we have a slope and we have a point, and you can choose either point, I'll just go ahead and choose this first one. We will have y minus a -4 equals -5, x minus a -1. We'll go ahead and distribute that -5, and then we can subtract 4 from both sides. Okay. So if we subtract 4 from both sides, we end up with y equals -5x minus 9. So what we have now is we have a point or a y-intercept of -9 and a slope of -5 over 1. So if we go ahead and place -9 is not on this graph, so we'll just go ahead and use this point. And you can use either. Let's use -1, -4 with this slope. So -1, -4 is right here. So we can go up 5 and over 1. And we can continue in that fashion. Whoops. Let's start that one over. So what we can do is put our point on the graph, which is -1, -4. And for a slope of -5, we can have 5 over -1. So we will go up. That's where so we're going to go up 5, and then we'll go to the left 1. And then we can connect those 2 points. Okay. And now let's go ahead and take a look at number 4. And in number 4, we have a line that passes through point 2, 3, and the slope is undefined. When you see the slope is undefined, we right away know this is a vertical line. So it's going to be x is equal to 2 if it has to pass through this 2 and be vertical. So we could go ahead and just put 2, 3 on the graph, and then we could draw our line right through there, and that is x is equal to 2. Okay, and then let's go ahead and take a look at this next section. We will be determining the slopes of parallel and perpendicular lines. Now, one thing we need to know is that parallel lines have the same slope, and perpendicular slopes have the opposite and reciprocal slopes. So I will tell you that if 2 lines are perpendicular and you multiply their slopes together, you're going to get a -1. So that's kind of neat. So opposite and reciprocal of each other, and same if we're parallel. So the slope of a line is given. Determine the slope of a line parallel and then perpendicular. So if our slope is -3/8, our parallel slope will be the same. And our perpendicular slope will be the opposite and the reciprocal. If we have a slope of 20, a parallel slope will be the same, and a perpendicular will be the opposite and reciprocal. If our slope is 0, our parallel line is going to have a slope of 0. But if we reciprocate 0, we are undefined. So if you think about this, a line that has a slope of 0, the perpendicular line is vertical. So the perpendicular line vertical is undefined, and the horizontal line slope is 0. Okay, let's take a look at number 8. Given the equation of a line that passes through -1, 2, and is parallel to this line, we want to give that equation. So the only thing you're going to do with this equation of a line that they gave you is find M, and don't use it for anything else. So we'll use, let me write that a little bit better. Use this only. Use only to find M, to find that slope. So let's go ahead and first find the slope of our new line, and all we're going to do is solve this for y. So we're going to add 3x to both sides, and we have y equals 3x plus 4, and what do you notice? The slope is 3. And this is our slope, okay? This is the slope of the new line. So now, if we have this point and we have this slope, let's write the equation of a line. Y minus the y value equals the slope x minus the x value. And we can go ahead and distribute that 3 and then add 2 to both sides. Okay. Okay, now let's give the equation of a line that passes through 6, 8, but this time is perpendicular. So using this line, we only want to use this to find M. We will not use it for anything else. So we're going to solve it for y. So let's go ahead and find M. So 2y plus 5x equals 10. We're going to subtract 5x from both sides. And we have 2y equals -5x plus 10. And we'll divide every term by 2. And we end up with y is equal to -5/2 plus 5. So what is our slope? The slope is -5/2. That's the slope that we need. Okay, so now we have this point, and now we have this slope. Now, since we're perpendicular, we will use the opposite and reciprocal. So we will use slope opposite, which would make it positive 2/5. Since we're perpendicular and we were parallel here. Okay, so now let's go ahead and fill that in, a positive 2/5. So we have y minus 8 equals 2/5 x minus 6. We'll distribute that 2/5. And then we'll add 8 to both sides. And negative 12/5 plus 8. So if we add 8 to both of these sides, you will put that in your calculator and you will get 28/5. And that is the equation of the line that is parallel to the given line. Okay, now we're going to create a linear function to model some data. And these are usually pretty quick. We have to read them carefully and get the data out of them. So there's a local hardware store and it charges $28 to rent a carpet cleaning machine for 24 hours and $10.98 for each medium-sized bottle of rug shampoo. We need to write a linear function that represents the cost of renting the machine for X days and with 2 bottles of shampoo. So let's write down that it's $28 per day and we have $10.98 per bottle. So we would have S of X, that function, is $28 times X days plus $10.98 times 2 bottles. So if we multiply that out, we'll get 28x plus 21.96. Now we want to evaluate S of 2 and interpret the meaning in context. So that means what is going on in the problem has to be described, the meaning of S of 2. So let's go ahead and find S of 2 first. Everywhere there's an X, we're going to replace it with a 2, and it looks like I wrote an 18 there, and I meant to write a 28. Sorry about that. Plus 21.96, and I put this in my calculator, and I got 77.96. What does this represent? It costs $77.96 to rent the machine for 2 days with 2 bottles of shampoo. Okay, that leads us to several cost functions. And they're not all cost. We have a linear cost function, revenue function, and profit function. And these should make pretty good sense. If you just take a look, B is going to be your fixed cost, and M is the variable cost per item. That's what you'll multiply by X. Now, the revenue, that's the money coming in, is going to be the price of the item that you have multiplied by the number of items, and that's X items. And if you want to know your profit, all you have to do is subtract the income, the revenue, minus the cost. Okay, so let's give that a try. Alina is starting a summer business power washing home driveways and sidewalks. And she is going to charge $35 to pressure clean a driveway and the sidewalk in front of the house. Her startup costs include her initial power washer cost of $330 and a fee of $2 per house that she has to pay to the HOA for using water at their homes. So the cost function is going to be that $2 times the number of houses that she goes to. So X is going to be the number of houses. And then we will add that initial cost of $330 for the power washer. Now, how much money will be coming in? She will actually earn $35. That's how much she's charging. She will get $35 for every house that she power washes. And now let's talk about the profit. Remember, we'll take our revenue minus the cost. So that profit function is going to be 35x minus all of 2x plus 330. And then we'll get 33x. I'll go ahead and distribute that for you. Which is equal to 35x minus 2x minus 330. So the profit function is going to be 33x minus 330. Okay? So now, how much profit, that's what we want, the profit function, will Alina make if she power washes 15 homes? So we want to find P of 15. So P of 15 is 33 times 15 minus 330. And that's 165. So she will make $165 profit. Now we need to see how many homes must Alina power wash to make $330. So now we want to find X when P of X is equal to $330. So using this equation right here, P of X is $330, and we need to solve for X. So what are we going to do? We're going to add 330 to both sides, and we end up with 660 equals 33x, and dividing both sides by 33, as you can see, we will then have 20 equals X. So 20 homes. The last part of this section is going to be creating models using linear regression. Now, we are going to be able to use our calculator to come up with this model. And the calculator's model that it comes up with, this least squares regression, is the best line. So that's the line or the model, the equation of the line that models the data that we want. So we're going to first graph the data in a scatter plot. We'll do that together. Then we're going to look for a trend. Then we're going to run linear regression on the calculator. And then we're going to check the result by graphing the model. So we're going to graph the model with the data values. Okay, so there's quite a bit to do here. So let's take a look. We have all of these points here. So the first thing we're going to do is use the stat button on our calculator, and we're going to enter all of the data in L1 and L2. So our X values will be in L1 and our Y values will be in L2. So let's see if we can bring this up over here, and we're going to clear our home screen, and we're going to press the stat button, and then we're going to press the edit, and now we're going to just start entering data. That was a bit easier. And now we'll go ahead and enter the corresponding Y values to those. Okay, so we have actually finished step number 1. And let me check. It looks like I might have, oh yes, I can see it right here. So we have 0.5 and then 1.3. And I really forgot that point, didn't I? And it maybe gave you a little bit more time to enter your values. There we go. Okay, so now we're going to use the stat button again and press calculate. Okay, so let's go ahead and do that. We're going to press stat and we're going to arrow over to calculate, and we're going to choose number 4. Okay, and we do have our X values in L1, our Y values in L2. You don't have to put anything in the frequency list, and we can just go ahead and press enter. And as you can see, we have this line, equation of a line. And so right here, and let me zoom in, as you can see, that's what we got. So really, we've got y equals 0.967x plus 0.3. So this is your B, and this is your A. Okay? So now how are we going to see these data values and these lines? So I'm going to also show you if we go ahead and press y equals, and we type in that equation of that line, 0.97x, and we could do 0.9, and why don't I just be consistent with this? Let me just do this, 0.97x plus 0.3. That way I'm consistent with the notes here. Okay, so we have now done that. We have pressed the y equal button, and we have input that into the equation. And I sort of skipped this number 4, which all we have to do is turn our plotter on. So we're going to press second stat, and we can see, and that would be on the Y equal button right above. This calculator is a little bit different. And we want to turn the plotter on, and you can leave the colors the same. And here is a scatter plot. This is a connected points line graph, and here's a histogram. And if you take statistics, you'll be using those box and whiskers plots. But we just want the scatter plot. We're confirming that L1 and L2 have our X and Y values. So now we have taken care of turning our plotter on, making sure we have that. And now guess what? All we have to do is click graph. So as you can see, there are our points that we graphed. The points that we were given right here. And then linear regression right here. Here is the line that best fits those data values. And you can move this around a little bit and such. And that concludes this section.